You should now know how to perform long division or synthetic division to find the quotient and the remainder of the division of two polynomials. In this video, we are going to talk about two theorems that will quickly help us determine the remainder without perform long division or synthetic division, and will also help us determine if a number is a factor or a zero of a polynomial. The first theorem we're going to talk about is called the remainder theorem. If f of x is divided by x minus c, then the remainder can be determined by f of c, which means we can evaluate the function f at the value c to determine the remainder. Example 3, given f of x is equal to x to the fourth plus 6x cubed minus 12x squared minus 30x plus 35. If f of x is divided by x minus 2, find the remainder. So we are going to evaluate the function at c, comparing x minus 2 with the form x minus c, you can see that c is equal to 2. So to find the remainder, we would evaluate the function f at 2. Substitute 2 in for x, we have 2 to the fourth plus 6 times 2 cubed minus 2 times 2 squared minus 30 times 2 and plus 35. 2 to the fourth power should give us 16 plus, this will be 8. 6 times 8 is 48 minus, this will be 4. 12 times 4 is 48. Minus, this will be 60, and then plus 35. Simplify this, we should get negative 9. So very quickly, we can determine that if we were to divide this f of x function by x minus 2, we'll have the remainder being negative 9. Now that did not help us determine the quotient, but that's not our goal here. Our goal is to determine whether the remainder is 0 or not. Because if the remainder is 0, that will lead us to the next theorem. It's called the factor theorem. If the remainder r is equal to f of c is equal to 0, then we can claim that c is a 0 of the polynomial. And we can also claim that x minus c is a factor of the polynomial. Example 4, given f of x is equal to the same polynomial that we just did, the question is negative 7 a 0 of the polynomial? And if it is, write a corresponding factor for the polynomial. To determine whether negative 7 is a 0, we want to find out what the remainder is going to be. Is it going to be 0 or not? So we are going to evaluate the function f at negative 7. Substitute negative 7 in for all the x's in the polynomial. Minus 30 times negative 7, and then finally we have plus 35. This will give us 0. Now, since the remainder is 0, which means that the function f of x, this function here, is divisible by x minus c, where c is negative 7. So the next step would be, we want to write a corresponding factor for the polynomial. Since it is divisible, we can say that one of the factor is going to be x minus c, which is x minus negative 7, and that equals x plus 7. So x plus 7 here is a factor of the polynomial f of x. What it also means is if you were to factor the function f of x, this function here, we would get something like x plus 7, and then could be multiple other factors here, which we'll have to go further to factor those. In example 5, we're going to try to factor this polynomial of degree 3. f of x is equal to 3x cubed plus 25x squared plus 42x minus 40. Part A, factor f of x given that negative 5 is a 0 of f of x. Well, if negative 5 is a 0, which means x minus c in this case is negative 5, which will become x plus 5. This has to be a factor. So right now, if we were to factor this guy, we will get something like x plus 5 as one of the factors, and maybe something else over here. Now, to figure out what this something else is, we're going to use synthetic division. We're basically taking f of x here, divide by the divisor, x plus 5. So let's do synthetic division. First, we're going to list out all the coefficients from the dividend. Make sure there isn't any missing terms. That should be an x cubed. Next, c is the 0, which is negative 5 here. First, we'll bring 3 down. Then repeat 2 operations, multiply and add. 3 times negative 5 is negative 15. 25 minus 15 is 10. 10 times negative 5 is negative 50. 42 minus negative 50 will give us negative 8. Negative 8 times 5 is 40. Negative 40 plus 40, that gives us 0. So this not only confirms that negative 5 is a 0 of f of x because the remainder is 0, but it also helps us find the other factor that will go in here. So that factor is going to be always 1 degree less than the dividend. So because the dividend is at degree 3, this will be of degree 2. So 3x squared positive, so plus 10x minus 8. And that polynomial will go right here. Now, the question is, did we factor completely? Let's see if we can factor this function, this pink function here, further by using the AC method. So 3x squared plus 10x minus 8. First, determine the coefficients a, b, and c. A is 3, b is 10, and c is negative 8. When I say ABC, I'm referring to the standard form of a quadratic function, ax squared plus bx plus c. We want to find two numbers so that when you multiply the two numbers, you get a times c, which is 3 times negative 8, and that's negative 24. At the same time, we want the sum of two numbers to be b, which is 10. So the two numbers should be 12 and negative 2. 12 times negative 2 is negative 24. Check. 12 plus negative 2 is 10. So now we are going to rewrite the trinomial 3x squared, rewrite the middle term 10x using the two coefficients 12 and negative 2, so plus 12x minus 2x, and then bring down the constant term minus 8. Now that we have 4 terms, we are going to do factor by grouping. Looks like we can factor out 3x here. So we have x plus 4. Bring down the minus sign, factor out 2. This will be x plus 4 as well because you factor out a negative sign, so we do have to change that negative to a positive. Factor again, you get x plus 4 times 3x minus 2. So the pink function there can be factored as x plus 4 times 3x minus 2. So in the end, the function f of x can be factored as x plus 5, which we got here, and then the pink function, which will become x plus 4 times 3x minus 2. So we successfully factor this polynomial of degree 3 completely. in this next example, we're going to do the opposite. The zeros are given to us. We're going to try to write a polynomial given the information. So the zeros are 1/2, square root of 6, and negative square root of 6. So with each zero, I can write a factor. With 0 equals 1/2, x minus c will become x minus 1/2. And then square root of 6 will be x minus square root of 6. And then negative square root of 6, the factor will be x plus square root of 6 because we're doing x minus c, which is x minus a negative square root of 6. Now, the problem wants us to write the function in standard form, which means we're going to have to distribute everything here. So first, I am going to distribute these two. So that will be x minus 1/2. Just keep that the same, and I'm going to use FOIL for this. Or you can use difference of squares to simplify this. So I'm going to use FOIL. X times x is x squared. X times positive square root of 6 is going to be plus x squared of 6. And then the middle 2, so negative 6, it's negative square root of 6 times x is going to be negative x times square root of 6. And then negative square root of 6 times positive square root of 6 will give us negative square root of 36, which will give us minus 6. Notice that these two middle terms cancel, so you have x minus 1/2 times x squared minus 6. We distribute again using FOIL, so this will be x cubed, that's the result of x times x squared, minus x times negative 6, so that's negative 6x, minus 1/2 times x squared, 1/2 x squared with the minus sign. And then negative 1/2 times negative 6 will be positive 3. So now the function is in standard form. So as you can see that in the result, the polynomial that we found has degree 3, which lined up with the question that is asking us. But that is just one possibility. We could actually insert a coefficient in front of the whole product. The coefficient could be anything you want. Could be a positive number, negative number, fractions, integers, and our answer would still be correct.